Alright, in this video we're going to talk about Unit 2 Objective 9, the derivative of an inverse function. On the screen you see right now is your derivative of an inverse function rule. I'll explain where it comes from and how we're going to use it in a minute, but if you wanted to go ahead and copy it down. We have if the point AB is on some function f of x, then just like in the inverse trig video, that -1 exponent that you see right here is not really an exponent, it's saying the inverse function. So the derivative of the inverse function of f evaluated at the point B is equal to 1 over f prime of a. So if AB is on f, then the derivative of the inverse of f at B is equal to 1 over the derivative of f at a. So where all of this stuff is coming from. On the screen you see in blue a random function. If you want to know exactly what it is, it's up here. Well, no, you can't really see because you don't see the A, B, C's, and D's. But it's some fourth power function that's not really important. But what we see is that we have the point 0.51 for an x, or -0.51 for an x value, and its y value is 0.06. So we have some value on this, or some point on this blue function, -0.51, 0.06. Now, inverse, if you remember, is when we reflect a function over the line y equals x. So if you look at the graph, you can see a gray dotted line, that's y equals x. We can show the inverse of our function, so that purple function is f inverse. So the first thing that we want to think about, the first thing we want to remember about our inverse functions is all we have to do to go from one to the other is switch the x, y values. And if we look at what's on the screen on the left, we can see in blue that we have the point -0.51, 0.06, and then in purple you can see that f inverse of 0.06 is equal to -0.51. So all we have to do is take a point on f, call it AB, and then the point BA is going to be on f inverse. So it's shown on the screen right now with AB, the point on f being -0.51, 0.06, and the point BA on f inverse would be 0.06, -0.51. So the next thing that we want to look at is if we look at the tangents of each of these things. Tangents meaning our slope. If we look at the slope of the tangent line at -0.51 on the blue function f, we can see that this tangent line has a slope of 1/2. Now, if we then look at the slope of that point in question on the purple function, it's 0.67. So 1.5, 1.5 is going to be the same thing as 3/2. So if we were to flip that over, 3/2, the reciprocal of 3/2 is going to be 2/3, and that's the slope of our inverse function at the point B. So again, if we're looking at this, we have some point AB on our original function, and that has a slope of 2/3 when evaluated at x equals a. Now, if we look at the inverse function, we can see the point BA, and the slope is 2/3 at x equals b. So that's where our derivative rule is going to come from. If we go back to this screen, the reciprocal of our derivative at a is equal to the derivative of the inverse at b. And we need to remember that we have that relationship where if AB is on f, BA is going to be on f inverse. So there's a couple different ways that we can see a problem like this on AP. So we're going to look at a few examples. And this is going to be the first one. AP is not going to ask a question like this, but it's an interesting question. So it says if f of 3 equals 8 and f prime of 3 equals 5, so that's a 3. It's kind of hard to see. What do we know about f inverse? So there's a couple things that we can think about. The first thing that we need to think about, and that's going to come into play, could be very useful every time we see an inverse function problem, is this right here tells us the point 3, 8. That point is on f. So we can take that information and we can say we know on f inverse is going to be the point 8, 3. So they also tell us in the problem that f prime of 3 equals 5. So if we think about our rule, 1 over the derivative of f, 1 over the derivative of f of a is equal to the inverse derivative at b. So if we're thinking about the problem we're on now, this 3 would be our a, this 8 would be our b, so those are b and then a. So our rule says f inverse prime of b is equal to 1 over f inverse of a. So what we know from this is, if we take those values we know, we can plug this in for b, and we can plug this 3 in for a. So we know that f inverse prime, of 8 is equal to 1 over f prime of 3. We know f prime of 3 is 5, so we know that f inverse prime of 8 is equal to 1/5. Now, AP is not really going to ask the question that way, but it's an interesting way to look at these. It's a way that's going to be useful for our other problems. So there's two other ones that are pretty quick, and they're like what you would see on AP. So here's one that you're going to see on AP. Sometimes they give it to you in a table like we have over to the right. Sometimes they'll just give you a couple of points. They would say something like f of 2 equals 6, f of 6 equals 8, f prime of 2 equals 1/3, f prime of 6 equals 3/2, or something like that. They would just give it to you in points instead of on a table. So if we look at this, it says if g is the inverse of f, find g prime of 6. So if we think about our rule, everything is in terms of f. We have f inverse prime. So the first thing that I want to do on a problem like this is just go ahead and write out that we know g of x equals f inverse of x. Now, in this problem, they want us to find g prime of 6, which means they want us to find f inverse prime of 6. Well, if we're going to find g of 6, we need to relate that back to f. So we need to think about the point f inverse of 6 is equal to some value. But we also know that f of whatever that value is equals 6. So that's taking advantage of that relationship a to b, or ab is on f, so ba is on f inverse. So if we look at our table, we can see that f of x equals 6 when x equals 2. So we know that there a 2 can go in here. F of 2 is equal to 6, so f inverse of 6 is equal to 2. So when we go to take our derivative, remember that our rule says f inverse prime of b is equal to 1 over f prime of a. So if we think about the point here being a, b, and we are trying to find f inverse of 6, that's going to help out pretty much. So f inverse prime of 6 is equal to 1 over f prime of 2. If we look at our table, f prime of 2 is 1/3. So f inverse prime of 6 is 1 over 1/3, which is equal to 3. So the other way that we might see this is if they give us a function like this: f of x is equal to x to the third plus x minus 2. G is the inverse of x. Find g prime of 0. So again, we want to think g prime, I'm sorry, not g prime, but g of x is equal to f inverse, it's inverse of x. So if we want to find g prime of 0, we're really trying to find f inverse prime of 0. So we need to think about the point f inverse of 0 is equal to some value. So we know that f of whatever that value is has to equal 0. So if we look at our function up top, we can come up with by inspection that if we plug 1 in, 1 cubed is 1 plus 1 is 2 minus 2 is 0. So we know that f of 1 is equal to 0. So f inverse of 0 is equal to 1. So now we have our point A, B, and we can jump into our rule. So our rule again says f inverse prime of B is equal to 1 over f prime of A. So f inverse prime of 0 is equal to 1 over f prime of 1. So we don't have a table, we actually have to figure out what f prime of 1 is. So f prime of x, again looking up at our function, f prime is going to be 3x squared plus 1. So f prime of 1 is going to be equal to 4. So f inverse prime of 0 is equal to 1/4. So that's going to do it for inverse derivatives. We'll see you in the next video.